Hello everyone and welcome to Introduction to Machine Learning Projects workshop, or we can say talk. This talk is given by Harini on behalf given by Harini, and I am the organizer of this workshop, Wedad Anbtawi, on behalf of FruitPunch AI. So Harini, you can start.
Yes, thank you, Vedad, for giving me this opportunity to present at FruitPunch AI. So, talking about myself, I got this opportunity to work with machine learning and artificial intelligence through Omdena. And of course, I would like to present a lot of things what I learned through many such organizations, projects, and everything. So, talking about that, one thing I always feel is missing among us is people might know what an algorithm does or what the model does, but many people do not know how we put things together and actually start working on that. So, for that, I would like to clear up this part where I want to talk about what are the aspects of machine learning and how we actually do it, right? So, I hope all of you are excited, just like I am. So yes, let's begin. All right. So as you can see here, what type of project? So that is basically, just a small second, I've got a kind of a technical problem. Yes. Yes. What type of project is the first thing we actually should be talking about? Now, as far as we have the machine learning projects into consideration, we can take a lot of aspects. For example, we might be working on text data. We can be working on image data. We can also be working on speech data. For this presentation, I will mostly talk about image type projects and text type projects. Yes. Now, problem statement. Now, how many of us know what a machine learning problem statement is? For example, we all see familiar examples of training a convolutional neural network to detect if that image, or basically recognize if that object is a cat or a dog. Yeah, accepted. But when you put it across and want to join things, what is the problem statement that you are trying to work for? What is the statement there? Is it like when you're trying to recognize a dog or a cat, what is that? What is the problem statement there? You're trying to recognize. So basically over there, you're trying to classify. That is one. So the first major thing that we'll have to note in a machine learning project is what problem statement are we trying to solve in, and in what way? For example, are we doing it based on some topic classification, which comes in the text data, or are we doing it in the form of image data classification? So the example that I gave of classifying an object as a cat or a dog, what are we doing? We're doing a classification. Now, where does association kick in? All of us are very familiar with Netflix and Amazon and everything, isn't it? But do we, all of us also know that we use machine learning somewhere or the other over there. But what is that aspect that we use? Where does machine learning come in Amazon or Netflix recommendations? It's called association mining. What is that association? Based on what you prefer, we get a prospect where all the related ones come to us. So how are those related ones coming to us? How are they being recommended to us? We have machine learning there, but it's again a different concept from classification. We are not trying to classify a movie or an object there. What are we trying to do? We are trying to associate it with our interest. So that is a different kind of problem statement that we should be addressing. Next, now until now we've been talking about association and classification, something like that. There is always this typical part of data analysis. What are you analyzing from the data? There are a lot of things that you can analyze from the data. What are those? For example, say it says, okay, Harini is from India. If that sentence is being given to you, what and all information can be extracted from that? Of course, you can extract my name, you can extract my country. That is it. But if you have a bigger sentence like Harini is from India and she lives in a place called Bangalore, how many more data can it be analyzed from that statement? That is something called as feature extraction. So it can be called as information extraction or feature extraction, in the way like when you give a text and try to analyze from that piece of text, we have it information extraction. And feature extraction is something like given an image. Okay, we're given an image and we are trying to recognize an object over there. How will you recognize an object? Now I'm giving a picture of a cat and you have to recognize the cat. If you have to basically recognize if it's a cat or a dog, how is it possible? How are we going to do it? That part comes from something called as feature extraction. So basically the algorithm tries to detect the features whatever is there from the cat or the dog and relates and then predicts the algorithms going forward. So apart from us classifying and associating the text itself, we also have data analysis part where we work on information extraction and the feature extraction from the image. So when you give a cat or a dog picture and you're recognizing it as a cat, the second question will be what type of cat it is. That is a feature. It's a feature of an object. So that's another feature extraction, which can be considered as the problem statement. Now here, let's talk about framing a problem statement. Now, whenever we have to do a project, I don't know, during my university days, it would be like mostly, what is your motivation? That used to be one slide. Every time I present a project, it used to be like a objective and motivation, which comes in two different slides. So for example, for machine learning and artificial intelligence, of course, there should be some kind of objective that you are trying to achieve, or some motivation behind it for you to start with that project. Now, for example, if you are analyzing some data, what are you going to do with that data? What is your ultimate aim of that data? That is your motivation. It will come from your motivation. Are you trying to stop domestic violence across the country? That can be your motivation, for which you will work towards your objective, and your objective would be to analyze the domestic violence in the country. And what's your data? Your problem statement depends mostly on data, and we all know machine learning cannot be done without data. So based on the data we have and based on what we intend to do with the objective, that is the motivation part, we actually frame a problem statement. A great example is about one project which I was a part of, which I will be talking at the end. But as of now, say that you are using artificial intelligence to analyze domestic violence across the country. So your objective is to use artificial intelligence to analyze domestic violence. And what's the motivation behind it? The motivation behind it is to show the government or the respect or the concerned persons, to show them that, see, so much of domestic violence is happening. Is there something which we can do with that data? Can we help them? How do we help them? We give the people the necessary information so that they can take appropriate action. And data in that matter, what data can we collect in terms of domestic violence? That I will keep it to the end because I have an entire project to explain about it. Now, moving ahead, first part of framing a problem statement was basically data. What is the data that we tend to use for our projects? We do have a lot of online resources available in the internet. We have a lot of free data sets. But say that the project you are trying to do not have data. The project that you're trying to do, that appropriate data is not found anywhere. How do we then make that data? So for example, say you are again trying to, if you are trying to do some machine learning algorithms, so basically run a model on the coronavirus data set or something, of course it's available in the internet. But say you are trying to work on a machine learning project for which you need lots of data, but you do not have enough amount of data. So how are we going to do that? That is the first aspect of any machine learning project, because we need to we need to focus on the data analysis, data challenges. So for the same, what we do is, if we do not find the data sets appropriate to our project online, what we will do is, let's go and make the data by ourselves. We have a lot of resources apart from the data sets available, where we can make data. For example, we can scrape the data from a few websites like Twitter and some newspaper data, with the help of which we can actually overcome those data challenges and make the data set accordingly. There's one more part of making the data set. I'm sure all of us know about something called as something called as testing data and training data. Training data is the data that you are making the model to learn. That is training data. So you're telling, hey model, look at it, this is the training data, learn from this and apply whatever you learned on your testing data. Where is this validation data set coming in? This is something I find that most of us are confused about. Validation data set comes in between training and testing data set. So for example, say that you you just built a model which is giving you some 98% accuracy on your training data, but when you apply it on your testing data, it fails miserably. It's giving you only like 30% accuracy or 20% accuracy. Why do you think that happens? It's giving a very good accuracy for one set of data, and for the other set of data it's giving a very low range of low range of accuracy. Why is that so? The reason is because the model is trained basically only to work in the trained data set. So for example, it will work fantastically in the trained data set, but it will fail in the upcoming models. That's why we have something called as validation data set in the middle, which will tell if that model will work on other data too. Just not on the training data, but it will also work on other data. This will basically prevent us from overfitting and underfitting models. That's why we always have a validation data set which comes between training and testing. Right. Now, let's talk about supervised learning. What are the, sorry, but yeah. Now, when we come to modeling itself, exactly, all of us know we have supervised learning and unsupervised learning. Those who don't know, also it's fine. Supervised learning, as you can see in the picture, is like there is always a human interaction with the particular person. Here in supervised learning and unsupervised learning, it's like you are just meant to deal with it by yourself, just like that. In supervised learning, in machine learning, when we take it, it's like you always take care of what the machine is doing. You're not just letting the machine to do everything by its own, but we humans interfere and basically help the machine in learning or training the model. In unsupervised learning, what happens is that we do not exactly tell the machine what to do. We just give everything to the machine and you're like, okay, fine, do whatever you want with the particular data. So when we talk about it, supervised learning is possible only if we have a labeled data set. Now, what is a labeled data set? A labeled data set is something where we have the particular text and its corresponding answer. By answer over here, it's in layman words. Technically, I mean it has a label. So for example, if I take a sentence, say, okay, like the football match is going to start in October. That is being categorized as football. We have a label to the text already, and we try to train a model based on that. That is supervised learning. And how do we actually train the model using a label data set? Is because the model will know, okay, if I have such sentences which have the words like football, cricket, I know it will belong to the sports category. But say sometimes you will not have a label data set. For example, you will have plenty of loads of data, but you will not have its corresponding labels. that data set will not be available. Again, what can we do? We can make the data set. This is the place where we have annotations come in. So what humans do in this is, we have huge amount of data, but we don't have it labeled. Humans will come and they will annotate the data sentence by sentence so that the machine can learn based on that. So if we don't have a labeled data set available, let's make a labeled data set using annotations. For that matter, we have both image annotations and text annotations. Image annotations is something like you you recognize an object and tell if it's a person or if it's a car or something like that. Text annotation, we either classify it, say for example the sentence is like, say it talks about football, you will not come to the sports label, so annotate it as a sports one or classify it as a sports one. Apart from this, you can also work on information extraction. By information extraction, I mean you can also get the month when the match is happening, right? So even that can be annotated if we do not have the data available beforehand. Now, unsupervised learning. Supervised learning is has the maximum benefits. We cannot basically we cannot get a better result than supervised learning model, but still we use unsupervised learning here and there. The supervised learning has more benefits when it comes to huge amount of data. Say we have like 5 lakh rows of data. In that perspective, we humans cannot sit and annotate 5 lakh data. What we'll do is we will throw the entire 5 lakh data to the machines, and we will tell the machines, okay, so go ahead and do whatever you want by yourself. You learn it by yourself or do whatever you want by yourself. Based on the labels the unsupervised learning gives you, on that particular, based on, basically we have this a lot of approaches where we use unsupervised learning. So say you're using unsupervised learning on 5k rows of 5 lakh rows of data, and they all give individual topics. Filter it. It can be, unsupervised learning can be used as a filtering approach in most of the cases, where you can filter data, and with the data that you are left, you can do annotations so that you can proceed with supervised learning. So that is one advantage of unsupervised learning, probably to reduce manual effort and also to filter out unwanted things. That can be done via unsupervised learning. Now, when we are trying to build a model, our first step would be determine the problem statement. After we get the problem statement, see what data can you use for that, prepare a data set, and see what are you trying to address. If it's a classification problem, or if it's an association problem, or if it's a feature extraction problem, what kind of a problem it is. After which you will see if supervised learning will best fit your model or unsupervised learning best fit your problem statement or model. After that, when you are trying to build a model, even if we take supervised learning, we have a lot of models which come in that. For example, we have a variety of classification algorithms which come in supervised learning. How do you choose which algorithm works best for your data? That is why we have a parameter. A parameter will basically tell us how our model works with different kinds of model, and we will choose the best model based on the parameter. That's why choosing the parameter is very important. Now, for example, say we're doing a machine learning project on detecting if a person is cancer positive or cancer negative. What parameter should you consider over here? Should you consider accuracy, or should you consider recall, or whatever it is? To be very precise in simpler terms, would you consider having a parameter which talks about a person who is cancer positive is actually given the report as cancer negative? So that person X is predicted that he is cancer negative, but actually he has cancer positive. Would you prefer that part of your accuracy or something to be more, or would you prefer that a person is actually cancer negative, but he or she is predicted cancer positive? You'll obviously choose the former one, because the latter one is fine. We all know that that person is cancer negative, so if he or she comes for treatment, we will identify that and it'll be rectified. But if a person is predicted cancer negative, and in reality if he or she actually has cancer and doesn't go for treatment, it's going to create a huge problem. So we have to choose a parameter which suits our problem statement the best. Now, all of us would have come across a lot of terms like topic classification, topic clustering, information extraction, association, and everything. In that case, what I would like to talk about is what is topic classification. Now, even in initial part, I mentioned it's a classification comes under supervised learning. Topic classification is where you are trying to categorize a piece of text into something which will be beneficial. Topic clustering is an unsupervised approach where we do not have the labels. Of course, we do not have the labels anywhere. And you are trying to ask the machine to predict completely. You are throwing enormous amount of data to the machine and telling like, okay, fine, you do whatever you want with this. And it's up to the machine to decide what it wants to do. And what it does, it'll try to cluster each data into some of the other groups and see find similarities between the data. It will form its own clusters. It's not reliable on humans for it, right? We are not providing it with a label. You are just giving the data and it will form clusters by its own. That is topic clustering. And information extraction is the part where, given a text, you are not categorizing it, you are not putting it inside a cluster, but you are finding further information from that piece of text. So for example, based on, say, you have 4 or 5 sentences which is talking only about the football match which is going to basically commence next month or something like that, football tournament for that matter. So in that case, you will have a lot of information: the sports name, which month it's going to start, who are the players, where it is going to start. All these information will also be necessary, right? So this is information extraction. From whatever you are having, you are trying to extract the information, but that information will be only in the text. So for example, if you have a text saying the football match commences next month, you can only get the words from the text directly. So you can get words like football next month directly. Machine learning algorithm will not predict new words from the data. It will just give the information whatever is there in the data that we provide. So that is information extraction. Association, as mentioned before, is a part where we find out similarity index. As to say, I'm ordering an Agatha Christie book today, and I will get recommendations on detective books and more of Agatha Christie's book. Why? Because my taste is similar to the other books. If I prefer detective, I'm also getting recommendations based on that. That is association. How much of my taste is actually going well with the other books? The similarity index works well over here. So that part is association over here. And now let's come to images. I don't know if any of you faced this, but I had this big doubt between object detection and object recognition before I actually did a project. So for example, object recognition is you are trying to, which is an object there. You already have an object. From that object, you are trying to say if it's a cat or a dog. But object detection is where you do not have the object at all. You are trying to predict where the object is. That is object detection. Object recognition is you already have that object and you are trying to label it or classify it. That is object detection. Object recognition. And object detection would be detecting a piece of or basically a part of an image or something like that. Now, segmentation. Over here, as we can see, this part of object detection is in a bounding box, which is in the shape of a rectangle, I suppose. So this is object detection. But if we use segmentation, what happens is that it gets only the exact image of the cat. So for example, the output is not in the form of a bounding box, but instead it can be of any shape in the form of a mask. So it's going to be covering the outlines of the cat. That is segmentation. That is going to give us a better result than the bounding box. And now again, yes?
We have a question about information extraction on the chat. If you can have a look about it.
Sure.
Or I can tell you the question if it is easier.
Sure. Information extraction is considered, or or possible also to ask a question directly, a question that needs to be interpreted from a Matrix movie text. Can I ask what color were the pills offered to Neo? So for example, well, I do not know exactly what kind of uh, I am not able to correlate with the Matrix movie and with the pills offered. But what I can tell is, say in information extraction part, you have the entire text which talks about, say, so and so is happening, like the pills offered to Neo was red in color. If you have the sentence available in that data, then using information extraction, you can identify what color were the pills offered to Neo. So did it answer the question? The answer to the question is again in the data that we provide. If we have that particular data in the text, then we will be able to predict it. If it says like, okay, so and so pills were given to Neo, then when we can extract that data from the piece of text. That is, does that answer your question, or would you like to? Yeah, thank you. Yes. So this is the advantage that we have with segmentation, wherein you get the exact mask of the object that we are trying to detect. But again, in that place, how does this algorithm works is, it will classify each pixel of an image as a cat pixel or a non-cat pixel. It's going to be like, okay, let me take this entire image. I will look into the green leaves. Is it a cat pixel or is it a non-cat pixel? That's how segmentation works, and that's why we're getting a non-even mask exactly over the cat, or which fits the cat. Now this part is data science myths are like, say, it's mostly going to be like a people think we can do it with the help of an end days challenge or something like that. But there is one thing which we always have to keep in mind while doing a machine learning project is, just using a neural network for us to recognize or basically detect an object wouldn't be enough. We should know what we are trying to do with that. We should know what we are trying to build with that. Building an end-to-end project is what we need, and that experience will be gained only over time. And I also suggest that we participate in a lot of real world projects, like real world data, the data that we have in the world, and make a machine learning model from it, rather than, instead of working on some data which is like 100 years old and it talks about the temperature, and you're trying to predict the weather condition 100 years back, then it would be better if we are trying to work on a live real world project with the data that we have available now and try to predict or recognize what's happening. And also, the problem statement is what which is very important here. Just having a problem statement to depict trying to predict a cat or a dog is not going to be enough. We can use the same model or the same concept somewhere else, which will give us a better result, or which will actually solve a problem around the globe. uh, Moving further, now this is one thing which I wanted to talk about for a longer time. This is one of the real world project that I did with an organization called as Omdena, where I worked in a project which was end-to-end based, from building data to building a model. We completed the entire process with a team of 40 other collaborators. So I would like to talk about how how this project went and how it helped me to build, how I'm talking about starting a machine learning project. So now, first thing, what does it say? It says analyzing domestic violence and online harassment during COVID-19, right? So what is the problem statement over here? The problem statement is nothing but, we are trying to analyze domestic violence and online harassment during COVID-19. That is the problem statement we have. That's it. You are given with this. And how can you start a machine learning project based on this? Just given the problem statement, you're saying use AI to analyze domestic violence happening. And this project is contained in India because we focused only on India. So that's one other criteria. But apart from that, how can we start a machine learning project based on this problem statement? First thing, we are clear about two things here. Problem statement is clear, motivation is clear. We did this project in partnership with Red Dot Foundation, who wanted to do something with the data, and they had submitted to the court to make domestic violence actual kind of violence apart from sexual harassment and everything. So we had the motivation and the problem statement right there. But data, how do we actually get the data to analyze this in India? We did not have data already available in the internet. We did not have the data. What we did was we made the data. Like I mentioned earlier, where can we discuss about domestic violence and everything? Where do you see now? We all know that lockdown has caused an increase in the domestic violence, right? But if we need data, which source are we most likely to prefer? What are we going to see? That one thing basically brought us to the part to align ourselves in specific tasks where we spoke about what data can be obtained to work on this project. So for me, as far as my country is concerned, I read a lot of this news of domestic violence in newspapers. So one suggestion was, let's get the data from the newspapers. So we'll have news, right? Like a 26-year-old was abused by her husband during lockdown. So that is one news. We can collect the data from news. Any other data sources that we can think of for this project? One can be Twitter. So Twitter is a way where one person expresses, whether woman or the man expresses himself or herself, saying that I've been abused with all this and I'm not happy at home, lockdown is pressurizing me and I'm subjected to domestic violence. We can actually get all these tweets and then analyze what's happening in our country. So Twitter was our other aspect of source. Apart from Twitter and newspaper, our major data sources, we also took Reddit and Google Trends for consideration. So we'll talk about Reddit and Google Trends at the end, but primarily imagine we have collected, okay, say we have not collected yet, but we know and we've chosen these two data sets. That is the newspaper data set and the Twitter data set. How are we going to get that data? We are going to scrape the data directly from the websites. So that's how we got the data using a few APIs. Now, cool, we've got all the data. How are we trying to get the data? Again, is a question. We will be getting the data based on a few keywords. Like, for example, I use the words like domestic violence, woman. We have a lot of words which relates to domestic violence. So with the help of those words, we scraped the data from all these huge sites, because if you scrape all the data, we will basically get all the data, right? Starting from sports to politics, we'll get all the data. But let's search or scrape the data based on the keywords, which is related to domestic violence. That's how we collected the data. Now again, when we search with the word violence, the keyword violence, we are most likely to get data which is related to non-domestic violence as well. So the man was attacked there because of there were a few violence attacks took place in Delhi, and a man was attacked. All that also comes under violence, and we will have the word violence in that particular form of text. So what did we do first? We need to do a bit of pre-processing to basically eliminate all this unnecessary data which is going away from the problem statement. For that purpose, we used unsupervised learning approach. So we had about 2 lakhs of data, which we reduced to 5K by performing topic modeling on that. And what was topic modeling? It was an unsupervised learning approach. What we did in that is we had like 2 lakh rows of data, and we ran a topic modeling approach over it with n is equal to 20. We tried to get 20 topics, and every sentence was aligned to one topic, and we chose the topic which is more suited to domestic violence. For example, if the topic was women, then we chose that text, that topic, and we left the other words like unnecessary words which contained like college, university, or something like that. We left all those unnecessary data. So unsupervised learning approach topic modeling was prepared to eliminate the unnecessary data. That was the first step of pre-processing we did. Now we've got 5K or data which is useful to us, which we think is useful, we still do not know. We do not have a label for that. We directly scraped from the internet. Do we have a label saying it is actually a domestic violence data? No, we did not have a label. What did we do? We did annotations. So sorry, we did annotate all of them. How did we do that? We used a few text annotation tools where we individuals manually annotated each data. So for example, if a sentence said the man the man abused his wife during lockdown, then I annotated it as domestic violence. If another sentence said that a girl was sexually harassed on the road by an unknown person, that for those particular type of sentences, we gave a new label called as sexual harassment. So we humans, we collaborators in the project annotated using the text annotation tool and gave them different labels like domestic violence, online harassment, sexual harassment, murder slash suicide if they were murdered, or if they tried committing suicide because of that particular problem, and a label called as other. Because although we performed unsupervised learning approach to filter out unnecessary data, we are not actually sure how whatever data we have is actually the best ones or something. So for the same, we used a supervised learning approach. To use a supervised learning approach, we needed label data set and we did annotations. After we got a label data set, what did we do? We separated the data into training, validation, and testing, and tried all classification algorithms on them. So we tried running random classifier, we tried running SVM, and settled on one classifier model, which basically gave us the best accuracy on the testing data. Now this is done. We got the data which is related to domestic violence, which is related to sexual harassment, which is related to online harassment. What are we going to do beyond that? We've categorized every piece of text, whatever we've obtained, and we know that this data belongs to domestic violence. What are we going to analyze further? What are we going to do? Now for that, it's where we think of our creativity. We can call it creativity, or we can call it knowledge or real world skill or anything. With the data from domestic violence, what else can we identify? For example, the data we get from news will have like 4 or 5 lines stating what happened with the wife actually, and when it happened, where it happened, many things. So what we did, our next step was information extraction there. And what did we do? We did something called as custom labeling. So for example, if you want to extract the place where the person lives from the piece of text, then you can do it directly. With the place, you will extract that information. But from the domestic violence data that we have, we are concentrating more on the other aspects than the place or the location itself. The reason being, the location will be easily detected in Twitter or newspaper because they come with the location sometimes. But when we had to do data analysis, we framed our own labels, and those labels contained topics like under which circumstance it happened. So many passages spoke in volumes about if the person was drunk, if the husband was drunk and actually abused his wife. Was that a circumstance? Or was there a fight which happened between both of them and he burned her or slapped her or kicked her out of the house? Under which circumstance did that happen? That was in one label. And apart from that, the other label was the type of violence. We know it's domestic violence, but even in that, the type of violence differs. If it was a slap, or if it was a cigarette burn, or if it was if it was like kicking the person out of the house. We have different type of violence attacks even for that. So we were trying to analyze from the data that we have what was the violence type in each line or each passage in each case, and so what was the trend. We try to observe, was it because of the unemployment rate that are we having this? So the circumstance comes under this. So the husband would have lost his job and wife is pestering for him to get a job so soon, and that pestering or that frustration basically made him to slap his wife and burn her. Basically he killed her because of that. And why that came, it is like frustration because of unemployment. So we were trying to figure out what was the major reason of domestic violence during lockdown. That was one. The next other types of data that we were trying to analyze from the text was the age. What was the age of the victim and the age of the survivor? What was the gender of the victim and the gender of the survivor? All these kinds of data. Or if that person actually had a history. Was it like it was the moment that he behaved like that, or has he been uh, has he been abusing his wife since a long period of time? And we also have another label called as medium violence, which talks about the online harassment. What was the medium that was used to propagate this online harassment? So that was one part. Sorry, I just closed by mistake. Yeah. So that was one part. Now for that information extraction, what did we do? Did we have a labeled data set? No. Again, we wanted to use a supervised learning approach even for that feature extraction. We tried to annotate the data from the text directly. We annotated the data which came under circumstance as a circumstance label. Like for example, if it says that the person was drunk during the incident, we highlighted the word drunk and put it on the label circumstance. So this is how we collected the data and used a name entity recognition model on top of it to predict the analysis on the upcoming data sets. So after we basically analyzed all this data, what we found was that there was this domestic violence during lockdown has decreased mainly due to unemployment, and online harassment was mostly targeted towards children. So the age of the survivor or someone was very less. They were mostly minor children. They were subjected to online harassment more than the others. So that's one thing which we found. And we also found the major age category under which the actors came under. We were trying to see that, and we were trying to see the type of violence attack. Was it murder killing, or was it an acid attack, or what was that type of violence which was more? So this information analysis, to use this specific model, the named entity recognition model, we needed a supervised approach and a label data set. We again created one using an annotation tool and tried running our model on top of it, and finally got the results for each label. The reason why this was complicated was because we made our own custom labels. It wasn't like saying direct so and so happened in a place called Delhi. That's not just it. It had more information into it, and that was very custom, which the machine will definitely not understand. So we humans are trying to make the machine understand by annotating by ourselves, and then moving ahead. So this project which I worked with is end to end, from making the data set to building a model for classification and information extraction. It was a complete project, and this was a real world project. The reason, because we worked with the data that we had in the internet and the current scenario that's happening in the world. We scraped data from newspaper sites and the Twitter sites, and that's how we collected the data. This is one thing which I wanted to share. Apart from this, basically I can answer the questions there in the chat room now, if any.
So guys, you can like put your questions on the chat or unmute yourself.
Hi, Harini. This is Priya. Thank you so much for your presentation. Awesome. I just wanted to know, how did you establish that the data you collected was seasonal? That is
Yeah,
related to COVID, and because domestic violence is a perennial problem, not just in India and everywhere else. So what features did you use to establish that it was due to COVID? Thanks.
Thank you, Priya, for firstly joining the session and for having this awesome question. For your question, the answer would be, we have two answers for it. Firstly, the data that we collected based on domestic violence or whatever was, it was ranging from January 2020 till May 2020. So that's the timeline of the data we collected, which covers pre-COVID, pre-lockdown, and lockdown. And by the end of May, Unlock 3.0 has started in India, where people actually started going out for jobs and everything. So we collected the data only from Jan to May, which covers pre-lockdown, pre-COVID, and lockdown periods. After we analyzed the data, what we what we found was the reason. Like I mentioned, we had a specific label called as circumstance. So from that, we did see a lot of abuse happen due to COVID-19 and unemployment. By COVID-19, what that data depicted was a woman was working in a hospital, and she came home and was later abused by her husband, saying that she shouldn't enter, and she was slapped because she was working in a hospital and she's more likely to be infected with COVID and spread it to others. So all those came under COVID label, and a lot of cases came under unemployment, whereas where the son killed his own mother because he did not have a job and his mom kept pestering about it. And when we combine the results in the form of a visual representation from January to May, what we saw was during January, yes, domestic violence was there, but the graph was pretty low. It spiked up extremely high during the end of April, or from the mid of April to end of April 2020, which is actually when the lockdown was implemented in India. And during that time, if we see the circumstance, it mainly was targeted towards COVID-19 / unemployment. Does that answer your question?
Absolutely. Thank you so much.
So another person asks what tools or architecture was used for this project. So by tools, we were just using a normal Jupyter notebook. That's it. Nothing much on any particular tools which is needed. We had to scrape data. And of course, like mentioned, we used a few annotation tools like Docano, which is a text annotation tool that was used, and Jupyter notebooks to code. That's it.
Is it okay if I ask one more question?
Yes, of course. I'm waiting for that. Yeah.
All right. Was there any data that you were able to collect outside of the internet? And what I mean by that is, were you able to get any access to clinical data because of injuries related to domestic violence?
All right. Yes. So basically, this was one of our challenge that we faced, the overcoming data challenges in this project. The reason being, newspaper data spoke widely of domestic violence cases, which is very high or critical. So for example, it spoke about things like only if it was at the end, if the woman was killed, or if she was forced to commit suicide, it came out in the newspaper. But not every domestic violence case was reported. That was the main challenge, because most of the domestic violence cases in India were reported via phone calls. And we were not able to, of course, track them because they were I don't know what type of data it is, but we were not able to track them. So we tried our best reaching out to other sources or some NGOs, of course, from which we did not get any good information because they all had their data private. So our major source came from government data, which is there on the official government website of India. That was there, of course, but that also gave us more information about how the trend of domestic violence has been here and there. But we did not have anything more than that, which can talk more. We used government data, Twitter data, newspaper data, Reddit, and Google Trends. That's it.
Thanks.
By project deployment, could you actually maybe talk about it? I didn't quite get your question.
Production deployment environments. So when you take any machine learning project beyond a research state, beyond a research environment to a production level, say your domestic violence project, I just want you to comment, not just on this project, just on your experience on previous projects perhaps, or something else on what a stack you used or architecture you used for deployment.
All right, so if we were to talk about deployment in most of these projects, all that was taken into consideration was the model that we used. And by deployment, we actually did not have an application or something which will tell you that you click on this and you get the data available or something. For our Omdena project about domestic violence, what we did was we used Tableau for visual representation to actually show how the data domestic violence increased from this period to this period and get graphs, all that. So that was a visual representation. If we were to talk about deployment, I would, a few of the projects professionally, I worked on AWS, where we actually build the model from scratch and deployed in AWS because of the amount of resources there. Otherwise, if it's something of voluntary work, I directly go do it in Google Colab and try to run it as functions. So basically one code trying to call out other functions with the help of calls and something like that. But yes, I hugely recommend AWS if we are doing it from scratch, because if we build a model and want to deploy it in AWS, that would be not better. Instead, we can start building the model from scratch directly in AWS. Does that answer your question?
Yes, it does. Thanks, Harini.
Sure. Anything else which I might have missed in the chat window? So assuming that there are no questions, before we close out on the session, one thing is, if we have doubts on exactly how people, those, I see one question about what's the advice for people who haven't done a project yet on machine learning, where we need to actually do, sorry, yeah, just a minute. Yeah, so there was a question which said, advice to someone that never made a real world project. I think if I can become an expert, I need to do a real world project, and how to actually do that. One such recommendation or suggestion would be is to join Omdena, because that's where I got, I started working with real world projects. Secondly, if you want to build your own real life project, first understand what do you want to build. For example, are you trying to analyze the trend of COVID over the world? Are you trying to analyze on COVID-19 data? If you are trying to analyze on COVID-19 data, what are those that you want to obtain from it? Understand that, and based on that, you can collect your data set. And then, like I mentioned before, you can, if you are mostly trying to work on COVID-19 data set, it's going to be of text. So we can use a few classification techniques, or if you want to extract more information, you can use feature extraction techniques. So to build a real world project, we need to be clear about what are we trying to do actually. If we get the code, for example, if we get the COVID-19 data set, what do you want to do with that? Are you trying to get the trend, or are you trying to relate that people who were most prone to heart diseases are infected with COVID more than people who did not have heart diseases? Are you trying to do an association or draw a similarity index? So that is first which we need to identify, beyond which everything will actually be good. Once we identify the problem statement, everything will be good moving beyond it. So I hope I did not miss any other question from the chat window. So yeah. I think Vedad, you can take over.
Yes, thank you, Harini, for this useful talk. So guys, if you have more questions or feedbacks, please send me by email. And also Harini will send you a follow-up email, including slides and record, and maybe some advices. I will check when it is, but it should be like within few days. So thank you for attending this talk, and hope to see you in the future ones. So thank you and have a nice evening or day. I'm not sure of your time.
Thank you, Vedad, for having me here. Thank you, everyone, for attending